Hello mathematicians, here is the video titled Division. So we did this when we read our book, A Remainder of One, and we're dividing when things don't work out perfectly, which means there's going to be some leftovers or a remainder. So when we did these problems, we will learn long division this year, but for now, we're going to be thinking about our multiplication facts to help us figure these division problems out. So everyone is watching. Everyone is listening, and everyone's super focused while they watch this video. Okay, 43 divided by 6. I'm thinking 6 times what gets me really close to 43, and you should be thinking that as well. 6 times what gets me really close to 43? Well, 6 times 7 is 42. But it's not 42, it's 43. 6 times 7 is 42, which means there's 1 left over, and that gets us to 43. Let's look at another one. 34 divided by 8. It's not going to work out perfectly because I know my facts of 8, and I know that 34 is not one of them. So I'm going to think 8 times what gets me really close to 34? Oh, 8 times 5 is 40. That's too much. Do 8 times 4. But 8 times 4 is only 32. 33, 34. 2 more will get us up to 34. 19 divided by 5. I know that's not going to work out perfectly either. So I'm thinking 5 times what gets me really close to 19? Well, 5 times 4 is 20. That's too much. Better do 5 times 3. 5 times 3 is 15. Ugh, not 19. 5 times 3 is 15. 16, 17, 18, 19. Remainder of 4. And our last example, just like our remainder of one day in class, 66 divided by 7. I'm thinking, what times 7 gets me really close to 66? Well, 7 times 7 is 49. I think I can get closer than that. 7 times 8 is 56. I think I can get closer than that. 7 times 9, there it is. Because 7 times 9 is 63. 64, 65, 66. With a remainder of 3. All right, let's look at some examples. When we do our division, I'm going to show you some story problems. And in one of the story problems, it's going to make sense that we ignore the remainder. Because in a real life situation, sometimes you're dividing things that it doesn't really make sense to divide the leftovers. So that's when you can't split up the leftovers. In some of them, we might change the remainder to a fraction. And that's when you can split up the leftovers. In one of the story problems we're about to do, we're going to change the remainder to a decimal. And that's when we're talking about money, because money is shown as a decimal. And then in one, we're going to round the answer up, and that depends on the question. So we're going to do 4 problems. One of them, we're going to do this in a real life situation. One of them will do this, one of them will do this, and one of them will do this. So we're going to do the problems mathematically, and then we're going to figure out in real life, what would you really do with those leftovers? So let's figure them out mathematically first, and then worry about what we would do in real life after. So my first question is, 3 students share 13 sticks of gum. So our mathematical question is 13 sticks of gum divided by 3 students. So we have 13 sticks of gum. We're going to divide it by 3. And I'm thinking, what times 3 gets me really close to 13? And I know that 4 times 3 gets me close to 13. 4 times 3 is 12. That means we have 1 left over. There's my 13. So mathematically, the answer is 4 remainder 1. But wouldn't people look at you really oddly if you said, how many pieces of gum do we all get? And you said, we each get 4 remainder 1 pieces. That would be so odd. Let's prove it with a picture really quick. 13 sticks of gum. One for you, one for you, one for you, another 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 one for you, and then you, and then you, and then you. Oh, and we have one left over. So the answer is everyone gets 4, and there's one left over. And that's what this means, right? Everyone gets 4, and there's one left over. Now, mathematically, this is the answer. So this is our mathematical answer. But now let's talk about what we would do in real life. Would you throw that piece of gum away? Absolutely not. There is no way that fourth graders are going to ignore the remainder. So we're not going to do that first one. I think we can split up the leftovers. We're going to choose this one. We're going to change the remainder to a fraction. Oftentimes, if it's food, you can change the remainder to a fraction. And I see that there's one piece of gum left. How would you divide that between 3 kids? You would split it into thirds, right? The first kid would get a third of a piece. The second kid would get a third of a piece. And the third kid would get a third of a piece. So instead of the answer being 4 remainder 1, in real life I would say each kid gets 4 and 1/3 pieces. So when you can split up the leftover, split it up into a fraction. So here is our mathematical answer, this first one. And the second one is our kind of real life answer. All right, let's look at another one. 4 brothers are given 25 pencils. They agree to share the pencils equally. So our math problem is 25 divided by 4. So I'm thinking 4 times what gets me really close to 25? Well, I know 4 times 6 gets me really close. 4 times 6 is 24. Ooh, not 25, 24. So that means there's going to be 1 left over. This is our mathematical answer. Can you imagine what a brother would say if their brother told them, we each get 6 remainder 1 pieces? They would think you were crazy. Or 6 remainder 1 pencils. They would think you're crazy. So we need to figure out what would we do in real life. And let's make sure that we're correct here. I've got 25 pencils. One for you, one for you, one for you, one for you. You, 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 and you. You, 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 and you. You, 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 you. First brother, second brother, third brother, fourth brother. First brother, second brother, third brother, fourth brother, and here's my one that's left over. And I can see that it is true. Everyone gets 6 remainder 1. See, 1, 2, 1, 2, 3, 4, 5, 6. Each brother gets 6, and there's 1 left over. But there's no way you would say that in real life. Hey, we each get 6 remainder 1 pencils. That's crazy. So which one are we going to do? We can't really change a pencil to a decimal, and we don't have enough pencils for everyone to get 7 pencils, so we can't round the answer up. So we're going to do this one. We're going to ignore the remainder. We can't split up a pencil into 4 pieces. I mean, we could, but it really wouldn't make sense. So this extra pencil, we are not going to split into pieces. We don't have enough pencils to give everybody a 7th pencil. We can't make it into a decimal, so we're going to ignore the remainder. So in real life, you would just say, we each get 6 pencils. And who knows, maybe the mom would put the extra pencil in the drawer in the kitchen or something, right? In this case, it doesn't make sense to split up that extra pencil. In this case, it makes sense to ignore it. So it's super fair. Everybody gets 6 pencils. All right, let's do a third problem. 4 girls split the cost of a $15 present equally. So mathematically, our question is 15 divided by 4. So I'm thinking 4 times what gets me really close to 15? Well, 4 times 3 is 12. And that's as close as we can get. 4 times 4 is 16. That's too much. 4 times 3. Let's see, that's 12, 13, 14, 15. With a remainder of 3. Okay? All right, so that is the mathematical answer. All right, everyone, we each owe remainder $3 for the pencil. Mathematically, what do we need to do? Or in real life, what do we need to do? And because we're talking about money, we're going to change it to a decimal, okay? Now, we will talk more about this in the future, so don't worry if you only partially get this. But let's make sure that we're correct. All right, $15, you owe $1, you owe $1, you owe $1, you owe $1, dollar, 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 and we keep going, and we see that each person owes $3, but oh my gosh, there's $3 left, right? There's $3 left, which means we don't have enough money to pay for this $15 present. And it wouldn't be fair for 3 of the girls to pay more than the other one. So I want you to think of each dollar being 4 quarters. Okay? Girl 1, if she spends an extra 75 cents, girl 2 spends an extra 75 cents, and girl 3 spends an extra 75 cents, and girl 4 spends an extra 75 cents, that will cover us perfectly. So mathematically, the answer is 3 remainder 3. But in real life, you would say we each owe $3.75. And we could check it. If I say the first girl owes $3.75, the second girl owes $3.75, the third girl owes $3.75, and the fourth girl owes $3.75, and we added it together, 5, 10, 15, 20. 4 sevens would be 28, 29, 30, and 5 threes would be 15. Oh my gosh, there's the $15. So 3 remainder 3 is the mathematical answer, but the real life answer would be $3.75. Last one. Lauren is buying albums to hold all of her 34 pictures. Each album holds 8 pictures. How many albums are needed to store all of her pictures? This is a very important word. Mathematically, the question is 34 divided by 8. So I'm thinking 8 times what gives me 34, or close to 34? And I know that 8 times 4 is 32. 3, 34. And there'd be 2 pictures left over. So mathematically, the answer is 4 remainder 2. What if Lauren went into a store and asked somebody working there that she needed albums for her pictures? I need 4 remainder 2 picture albums, please. The person would think she was crazy. So let's think of what we would do in real life. And the only one we haven't done yet is round the answer up. And that word all told us that we need to round the answer up. And the reason we need to round the answer up is that 4 albums is not enough because there's 2 pictures left over. And she wants to know how many albums for all of her pictures. So if 4 albums is not enough, better get 5 albums. The last one won't be totally full, but at least she'll have enough for all of her pictures. So for each of these problems, we figured it out mathematically, and then we figured it out what we would do in real life. Mathematically, and then real life. Mathematically, and then what would we do in real life? And finally, mathematically, what's the answer? And what would you say in real life? All right, kids, thanks for watching.